All right, here we go. So properties of logs. Um, Now remember, when you have a product, do you guys remember how to break it up? Yep, good. Yes, yeah. Kind of like exponents, right? When you have like 2 to the third power times 2 to the second power, you add those exponents, right? It's kind of the same thing. If you're multiplying two powers, you add the exponents. If you have a log and you're multiplying the two numbers inside, then you break it as an addition situation, right? Or ln r plus ln s. Next up, log. Yep, you subtract. You guys got it. Ln r minus ln s. And then, of course, this one here. Okay, we're good? All right. All right. So let's go through. Let me do maybe A through C, and I'll have you guys try. Say yeah, A through C, and I'll have you guys try D through D, F. So for this one here, you're gonna break up like this, right? Natural log of 9 plus natural log of y. Here you do log 8 plus log x plus 4 log y. And that's let me make that 4 look a little better. And of course, that's easy. Just log 2 minus log y. Okay. Any questions so far? This seems to make sense, right? Okay. Try D, E, F. Be very careful. And then I'll share. I'll freeze my screen. And I'll share in a sec. All right, here we go. Here we good. Yeah, Audie, go ahead.
What if like the exponents are 4 power? Does it become 4 times 1 plus log x?
Oh, sorry. Which part? Sorry. Yeah. What about it?
So 4 like times log 1
Okay, I'm glad you brought that up.
So that would happen before that's a for instance. Because you get PEMDAS, right?
Yeah.
So it's 1,000 times x to the 4. That 4 is only to the x, not to the 1,000. If you put the 4 in front immediately, then you're telling me the 4 is on the outside, which is a much different number.
And also means it'll be entire.
So what you want to do is break it up as a product first, then do the power property of the log x. Yeah, so be careful.
And I'm glad, brother. That's a common error I've seen before. So yeah, you don't want to do that, right? Like notice for E, right? The square root was only for the x squared plus 5, not for the x in the bottom. So 1/2 only went in front of that log, and ln x was its own thing. So be careful about that, right? Okay. And guys, if you have a chance to evaluate, by all means do so. Log of any base when one's the input is always 0. And then log base 10 common log of anything of power 10 should be easily evaluated, like log 1000 scores 3. So if you can evaluate, please do so. All right, let's move on. That was easy. All right, we're rolling along here. Okay, now we're going to condense. Now, condensing actually is incredibly important. I say it's more important than expansion because we have all these like crazy log equations that you got to whittle down to so you can solve. You want to be able to condense. Condensing is actually, I think, more critical than expansion, especially in calculus. We may have to deal with these kinds of situations, right? When we're trying to simplify things and apply some calculus principles down the road. So this one's easy. I'll do the first three again. You have this, and then that's log. Okay, why don't you guys try DEF? I'll freeze my screen. You guys have at it. All right. Hopefully you guys got that. Or if I made a mistake, please let me know. Bless you. We're good? Cool. Can I move? All right, let's keep moving. All right, the proof of the product rule. It's actually kind of cool. If you think about it, that should be R, right? B to the X equals R, and B to the Y equals S. Does that make sense so far? Right? If log base BR equals X, R equals B to the X. Log base BS equals Y, B to Y equals S. So what's R times S? B to the XY, right? Oh, sorry, B to the X plus Y, my bad. Which really, if you think about it, or actually, hold on a sec. Let me back a little bit here. B to the X times B to the Y, which of course is that. Actually, hold on. I'm trying to understand how these notes are set up. Okay, that makes sense so far, right? B to the X times B to the Y combine as one power, B to the X plus Y. Now, if you put it in log form, this equation, put that equation in log form, it's going to look like this. Log base B of RS equals X plus Y. Does that make sense what I just did? How I transformed that, right? Like I made the base B, the input's now RS. Remember, when you write a log, the whole point's to isolate the exponent, right? That's why I have logs in the first place. To isolate exponents. The exponent was X plus Y previously. Now it gets isolated, and the other side's a log. Well, think about it. Log base B RS. What was X again? X is log base BR, right? What's Y? Log base BS. And that's why it works. That's why it works. It's kind of neat. Usually I don't do that with my algebra, at level algebra 2 students, but it's kind of neat. So, and it's pretty much analogous to properties of exponents, right? You could do it for the quotient rule or the power rule, but it's not necessary. I think you guys get the point. It works. All right, questions on that one? Okay, next up, change base formula. This is back in the day before you had these fancy calculators, before your calculators can do like the subscript. Like you do any log you want in TI-84 calculator. So back in the day, like actually when I was in high school, we didn't have that special feature. So if you want to evaluate a log that was not base 10 or base E, you would have to do this. Or you could do this. It's called a change base formula. Um, or it could really be any base you want. I mean, if I wanted to, I don't know why you do this, but you could do log base A of X or log base A of B. So that could work too. Okay. So here, let's look at this one now. Let me move down. Actually, I won't move down. Let me move down. So X equals B to the Y power. Where we know that. If you take a log of both sides of base A, I suppose. So we're doing the same base on each side, right? And what property can I use next on the right side? When you bring the Y to the front, what's that rule called? Power rule. Thank you, Adi. And then we isolate Y. What does Y equal? There we go. Okay. Okay, we're good. All right, here, let's do the same thing. And we'll have to use a calculator clearly. So log 19 over log 5. I'm just going to common log it, by the way. 259 over log 12. Or log 29 over log 0.2. Some common mistakes. And actually, let's work that. Let me get a calculator really quickly. Hold on a sec. So you could do this, guys. Alpha window, option 5. I mean, that's super easy. But you can also do log 19 over log 5 or ln 19 over ln 5. Super easy, right? Also, if you go to math and option A, that works too. So you have all these options here. If I did like log base, I don't know, log base 2 of 19 divided by alpha window, option 5. I know I'm kind of going the deep end here, or kind of being a dead horse here. Yeah, these all work. 1.829, these all work. They're all fine. So you get 1.829. Yeah, either of them are fine, right? Okay. Next up, we'll do this in the calculator. So you get those as your answers. Okay. Now, common mistakes. Say, for example, a log base 3 of 4. Can I simplify that? This can't be simplified. But some students will do this, which is not true. You can't do that, right? You can't just multiply 4 and 5 like that. So that's not a true thing. If you have log base 3 times log base 3 4 times log base 3 5, just forget it. It is what it is. Like if you added them, go for it. Totally. Right? But unfortunately, you can't do that. Also, another mistake I've seen some students do this for like log base 3 of x plus y. Can I do anything with that? No. Like some students will do this, but that's not a thing, right? You can't do that. So again, that can't be simplified. So just be mindful that you're using the properties correctly. That's what I'm trying to say. I think there are other common mistakes too that I don't think it's just two, but anyway. Okay, we're good so far? All right, so let's work on this. I'm going to do the left column. Have you guys try the right columns? True, false stuff. True, false stuff. So just make sure we have any misconceptions. If we do, let's clear them up. That is totally false, right? That is totally true. That is totally false. That is totally false, right? Those are not things, right? We can't say that. Now, if you wanted to, for the last one on the lower right corner, you can move 2 to the front, but then that would be log base 5x plus log base 5x, right? So you can't, that's false. Take a look at the right side. I'll freeze the screen. Take a moment. I'll write my answers and we'll check. Okay, here we go, guys. False, false, true, true, true. You got it? You good? All right, let's keep moving. Questions? We're good? All right. Okay. No problem. I'll do it again. No worries. There you go. Right. Because the third one on the right is the power property. The second one on the right, you could do that. That's division. The fourth one on the right, you could do it because that's change of base. Right. Clear? Let's go. All right, we're on page, oh, last page. There we go. Nice. So composition functions. When you plug a log function into an exponential function, the bases are the same. They're actually inverses of each other, right? So for example, this is just going to equal 4 if you were to work it out. That's just going to equal 2 if you work it out, right? So like, for example, if I do log base 2 of 4, that's 2. And if I do 2 to 2, it's back to 4, right? Or for this one here, do f of 2, which is 2 squared, which is 4, and then log base 2 of 4, which is back to 2. So they undo each other, right? So f into inverse function if only if f of g of x equals g of f of x, which of course equals x. So let's do this again. Um, which I don't know why there's 3 spaces here. Hold on.
Then you want to start B to the B of X.
Nah, you're probably right. Good call, Aria. And these undo now, please don't cross these off. That's not really what's happening. Some students do that. It's not technically crossing off. If you actually really want to think what's happening,
It's kind of like this, right? Thinking here, if you have like log base b x equals y. Hold on a sec. Go back up a little bit here. B log base b x equals a box. Let's say that happened. Yeah. So it equals something up. So you move this base here. Let me actually color code it. That might help a little bit. So you move this base down here, right? You move this box over here. You move this over here. Maybe you can actually make that black green or forest green. Yeah, right. So what goes in the box here? What to make these equivalent? What has to go in the box? Yeah, so exactly. So that's really what's happening. You got to do each other. So don't. Some students will do that. That's not good because that's not a division or patient problem. You don't want to really do that. It's just if you were to kind of go through the motions of like transfer from law to the exponential vice versa, they just don't do each other. So, but I think the quick and easy way is just hey, you got a log within an exponential function. They start saying they're not going to show up. Or the other way around. If you have a take a log of an exponential function, which is the next part. If you're in log base b of b to the x, actually in this case I could do the power property. That's kind of nice, huh? And what happens when the base and the input are the same? What's the value of that log? Exactly, good. X times 1, which of course is x. So you could do that. That's another way of looking at it. Or you could try shifting it back to exponential form if you want to. So point of view. So we found 2 important properties of logs. Log base b of b to the x equals x. And of course, b log base bx equals x. So here, that's 4. Here, that's 3x. And here, it's 2x. So now we know. Pretty easy stuff, right? Now, of course, if the base of the log part is like a different base that doesn't come, let's say it's ln, I don't know what you would do. You just kind of leave it as is, right? So just got to be mindful about that. And that's it. We're done. That was easy. All right. The homework is pretty lengthy, but it should go by fast. I trust you guys can probably knock this out pretty quickly. It's homework 10. You're asked to graph a log function using the cloud methods, kind of review old stuff, using log properties for 2 through 6, as likewise 7 through 11. Keep doing log stuff down the road, solving equations. So yeah, I'll end the video.